Welcome, everyone. We are going to talk about maximizing development efficiency through CI/CD strategies. Let's jump into a quick intro first. I am Tamás Bazsonyi. I previously worked as a full-stack developer. After that, I got into manual QA, test automation, the mobile development itself, and DevOps for mobile. And currently, I'm working as a solutions engineer at Bitrise. Bitrise is basically a mobile DevOps platform providing support for and automation for the CI/CD side, release management, caching, and basically anything that's mobile DevOps. Let's look at the numbers. So we are going to look at a company that has 10 engineers. Developer hourly cost is, let's say, 60 euros per hour. The average number of builds that they are running is 50 builds per day. And the average execution time is 20 minutes. If average improvement of the development of the build process would be 20 minutes that we are aiming to get to. What does that mean? It's basically 1,000 euros each and every day. And if we look at the whole year, then it is around 2,500 euros of saved. So how does the process look like? We have building, testing, and release. And where can we potentially save 20 minutes of build time? The answer is through the setup and optimization of all of these three different points of the process itself. AI is quite a huge topic right now, so let's involve AI as well in the whole optimization process itself. We offer an MCP server, which basically allows you to connect your chosen client with your Bitrise projects and build data. And basically through these, you would be able to query quite easily the data that is stored on Bitrise's side for the different build processes that you have. Let's just quickly run through on the setup itself. You simply open up the MCP servers list. You configure your connection to the Bitrise MCP server by using the API token so that AI would be able to query the different builds and data stored on Bitrise's side. And then you just ask away your questions. So what were we looking at? We are basically looking to optimize our setup to save that 20 minutes per build. We can simply input the question, and the AI will generate a couple of suggestions that we are going to go into a bit more detail. But first, a quick question to the audience. What do you guys think? What tasks can AI help you with in your CI/CD setup? Raise your hands if you think in code reviews, only in code reviews. Raise your hands if you say only through issue analysis. Raise your hands if you say only in optimizations. And raise your hands if you think all of them and more. And you were the first, so you are getting a plushie for your good answer. Which one would you like? Awesome. So let's move into our next section, basically AI versus expert. We are looking at the different suggestions that AI came up with. There were 5 different ones, but if we distill down to the essence all of these suggestions, there are 3 possible options that AI suggested to improve our build times. One is the Gradle parallelization. The other one is using build cache. In this case, of course, the Bitrise build cache, because we were looking at the Bitrise solution, but basically any kind of build caching solution. And the third one is splitting and parallelizing workflows. So let's look at the Gradle parallel flag. We simply added that given flag to the Gradle execution and started to run a couple of builds on one of the machine configurations. We can see that this was a 8 CPU, 32 gigabytes of RAM machine that we started to test with. And we can see that the speed improvement is somewhere around 30, 40 seconds, which is good, but it's not really what's going to get us to that 20-minute improvement that we are looking for. So this is where the expert part comes in. What is a really good way to optimize? Basically, throwing more hardware at it. So let's run a test on a stronger machine. We doubled the CPU and the RAM, and we can see that the performance already improved quite a bit. And basically, this machine configuration is much better at accommodating the Gradle's parallelization options. And we can see that from 5.5 minutes, the execution time dropped to less than 4 minutes. And just for fun, let's look at an even stronger machine. We can see that even though we quite heavily increased the CPU count and the RAM as well, the performance didn't improve that much. And if we are looking at without the parallel flag execution, that even got basically longer. So what can we do to make these analysis and machine configuration selection a bit easier? Basically monitoring, looking at the CPU, RAM usage of the different executions, trying to spot how heavy is the load on the given machine for that specific execution. And based on this, we would be able to choose the correct configuration. And just to show you real quick how the executions looked on the different configurations. So on the 8 CPU one, you can see that the load was quite heavy on the machine. On the 16 CPU one, it got much smoother. And yeah, on the largest one, it was pretty much an easy task for the execution. So basically, by choosing the correct machine type and enabling parallelization, we managed to save 3 minutes already. If we are looking at the integration tests and release builds, this would basically account for a 9-minute speed improvement from that 20 minutes. So we are almost halfway there already. Let's look at one of my favorite topics, the build cache itself. And let's start with a question. If you already attended one of my talks, this might be familiar, but let's run through it. So what do you guys think, in an ideal case scenario, how much faster can remote caching make your builds? Raise your hands if you say 50%. Oh, no one. That's new? Cool. Raise your hands if you say 70%. Raise your hands if you say 95%. And raise your hands if you say 99%. Awesome. 95 is the correct one. So in an ideal case, that would be a 95% improvement. And you were the first, if I saw correctly. Which plushie would you like? Awesome. So the improvement was quite a lot. Let's look at, in general, a couple of different caching solutions. There is definitely the dependency cache, which is there to basically allow you to not download all the different dependencies from the dependency hosting solution each and every time. Instead, store it in the cache itself. There is the remote build cache. For remote build cache, basically the main execution time factor is the network latency. So the location of the build server and the cache server is super important. So a co-located solution basically allows you to minimize that network latency. And there is the configuration cache part as well. And let's just look at the configuration within a workflow. How would that look like? You basically enable the remote build cache by, on Bitrise's side, for example, adding a single step or changing your configuration in the Android project, basically. You add the dependency cache by dropping in a restore and save cache step, and the same goes for the configuration cache. So the configuration of the workflows is super simple, but let's look at the actual performance improvement that this brings us. We have the first run. You can see at the top we have a build with all three caches. After that, a build with dependency and remote build cache. The third one is build with dependency cache. And the fourth one is the build without cache. What can we see? The second one, where we had the remote build cache enabled, took basically longer than running a build without cache. Why does this happen? Basically, the first execution is used to populate the cache. So the very first execution will always be longer when you are using remote build cache, but from the second one, you will see improvements. And let's just look at what type of improvements you would be able to see. So we were using the DuckDuckGo project for the tests. And basically here, what we saw is that the initial build took around 4 minutes. And the one with dependency caching took 4 minutes and 18 seconds, which is a bit longer even. But now we can see that the build with remote build cache enabled went down to 2.5 minutes. So this basically highlights how much faster you would be able to execute your builds simply by adding the remote build cache. And if we look at the numbers, basically, you are seeing a 35% improvement in the build times. It's awesome that we have the build cache set up, but usually, if you are iterating on a project, you don't just want to configure something once and leave it like that. You want to figure out how you can improve the whole setup. For this, you would be able to use different analysis tools as well. One of them is basically getting the invocation details. So trying to figure out what is the cache hit rate for the specific executions, which are the commands that we're running, and basically what was the duration of that execution. And based on this, critical path analysis is super important. Basically, the critical path is the chain of dependent build tasks that are accounting for the majority of your execution time. If you can make the tasks that are in this chain cacheable, then you can basically speed up your builds. In a virtualized environment where you are starting a clean build each and every time, you won't really have any history, but with a bit of additional configuration, you would be able to set up diagnostic builds where you are basically storing the execution history in a cache and restoring it during the executions. So it would be able to figure out what was the exact reason for that specific task to be executed. In this case specifically, it was the version code and version name that got changed, and this caused the re-execution of the different tasks. And definitely another crucial part is comparing the invocations. There can be always differences in the environment itself, different Gradle versions, different environment variables that are being used during the execution. All of these could cause issues with the cache hit rate, basically decreasing it and making your builds run longer. If you are comparing the different invocations, that would allow you to look at the configuration of all of these. So we talked about the different cache options. And let's dig a bit deeper into what happened exactly. So the configuration cache wasn't really helpful for the top two builds, which was already using build cache. But what we are seeing with the dependency cache, that it actually made the whole thing run basically longer. Why could this be happening? And let's jump back to an AI versus expert kind of topic. Let's just ask AI what happened there. So we are basically asking AI to look at the specific build and try to figure out what was causing that longer execution with the dependency cache enabled. And what we are getting as a result is that there weren't any dependency downloads during the execution, and this is causing the issue. If we look at the specific builds, we will see that there are dependency downloads in there. So I wanted to include this part just to give you a bit of a heads up that it's always good to double check what you are getting out of AI, even though it can be super helpful, but there can always be a bit of a hallucination in what AI says. So we shaved down 35%, which is 2 minutes for the unit tests, the integration and release builds, and we are at 15 minutes already, which is quite awesome. But we are still looking to get to that 20 minutes. So let's look at the third option, split and parallel workflows and test sharding. This is how the unit tests look. You can see that without shards, it takes 2 minutes 20 seconds. If you shard it, you see that it takes roughly the same amount of time. This is simply because the unit test execution was so fast that running in parallel doesn't really speed up the whole process. The building is basically taking the same amount of time. So it doesn't really make sense to split up the workflows here. But if you are looking at the UI test part, you can see that on the right-hand side, well, yeah, your right-hand side, the executions were almost around 18 minutes. But if we are looking at the sharded executions, it goes down to under 12 minutes. So we are basically saving 6 minutes by sharding our UI tests. And this is basically the best use case, I would say, for test sharding, because UI tests tend to be super long running, and running in parallel can always help you either decrease the overall execution time of a single test suite or allow you to run on multiple devices in parallel without making your whole test process super long. Yeah, and we can quickly look at distributed test executions as well. In this case, we are basically allowing the tests to be run on multiple machines at the same time. And you can see that roughly 2 minutes were saved because of the distributed test execution. And one final part about the parallelization, basically what happens here is that you would be able to split up your builds for the different environments and different configurations into multiple workflows and basically run those in parallel to save as much time as possible. So with that additional 6 minutes savings on the UI tests, we are over the 20 minutes mark, and we are getting close to the end as well. So I just wanted to also mention a couple of other use cases for AI in your CI setup. One is basically an AI code reviewer that we also have in our offering as well, where you would be able to use AI to generate a quick summary of your pull request and basically pass that back to Git as a comment. Or we are also working on field build summary and analysis, which basically gives you an outline on what the specific issue is in the build logs and tries to suggest different solutions for that specific issue. And that's all. You can find us at booth 25. If you guys have any questions or if you want to chat about CI/CD or mobile DevOps in general, feel free to drop by and we can chat a bit further. Thank you so much for your attention.